Hi ladies, this is Mrs. Lofus here. In this lesson, this is 5.7 for Algebra 1. We are going to create models, linear models, to predict what may happen within a correlated set of data for future interpretation. So to start, we have 4 new vocab terms. So the first one is best fitting line. We introduced that in 5.6. Then interpolation, extrapolation, and zero of a function. So take a minute, copy down these definitions, pause the video while you work. Okay, so first, as you have these definitions copied down, let's look at the difference between interpolation and extrapolation. So first, interpolation is using a line or an equation of a line to approximate a value between 2 known values. Okay, so we already have the values of 2 points. How that differs from extrapolation is extrapolation, we're using a line or its equation to approximate a value, but this value is outside of the known range. Okay, so interpolation is in between 2 points that we know, and extrapolation is outside of 2 points, or outside of the range and domain of the data. And then lastly, zero of a function. So f of x equals y. We're looking at what y is when x is 0. In this lesson, we're going to be using our graphing calculator. So take out your graphing calculator now, and I'll show mine up on the screen. So this is the TI-84 Plus. If you have somewhere between a TI-84 and a TI-87, these functions all should be pretty much the same. So in this problem, we're looking at interpolating using an equation. So we could plot these data points by hand like we did in the last lesson, or we could use our graphing calculator. I think it's a little easier to use our graphing calculator, so we're going to learn how to do that in this lesson. And it says the table shows the average National Football League, or NFL, player salary in thousands of dollars from the timeline 1997 to 2001. Okay, let's just make this so we can see the whole problem. So the first thing we're looking at is, if you notice the years, remember what we said last lesson about the years? So we're looking for years since something. So we could use 1997 as our starting point. Okay, so I'm going to call this actually not the x value of 1997, but I'm going to call it an x value of, actually I'm going to call this 0. Okay, so this is 0 years since 1997. 1999, that would be 2 years since 1997, 3 years, and 4 years. Okay, so first thing I'm going to do is I'm just going to rename my x-coordinates so that I can actually plot those. So first we're going to make a scatter plot. So we're going to make our scatter plot by entering our data into our graphing calculator. The top row, or the years, are going to be on our x-axis. So to do that, let's go into our graphing calculator, and we're going to press this Stat button, and it brings us to this menu, and we want to edit. Okay, so I'm going to choose option number 1. And I'm going to clear the data that's already in there. So to clear my data, I'm going to go up to my list, and I cleared 1, and I'm going to now show you how to clear list 2. So I moved using my arrows, I'm going to go up and select the actual L2 and press clear. And once I've cleared it, I'm going to press enter. So now I have nothing in my list. So I can go ahead and put these data points in for my x values. So I can just type in 0, 2, 3, and 4. Okay, those are my x values. And now my average player salary, those are going to be my y values. Oops, I have x-axes here. This should be x values. Okay, now I'm going to go ahead and enter all of my average player salary as my y values. So I'm going to move over to my calculator. In list 2, I'm going to type 585, 708, 787, and 986. Okay, so now I have my data in my list. So now what I want to do with this so that I can see them all plotted and so I can create a line that best fits. First, I want to show you what it looks like already as I graph it. Okay, so the first thing I'm going to do when I graph it is I'm going to change my window. So if I go too fast, just pause the video as you need me to. But I'm going to go to my window, and I'm looking at my x values, and it goes somewhere between 0 and 4. So I'm just going to make my x value window 0 to 10. That's fine. With a scale of 1, that's okay. My y values, though, they go from 585 to 986. So I'm still going to start it at 0 just because I like the way that looks, starting my y at 0. And then I'm going to make my largest y value 1,000. Okay, because in my data, my largest is 986. So if I can see it at 1,000, that'll help me to see the whole thing. Okay, now I'm going to graph this. Okay, I don't see anything on my graph, and that's probably because this function stat plot is off. So I'm going to press second, because that blue button will highlight anything that's blue for me. And I'm going to select stat plot. And I can see right here, plot 1 is off. So I'm going to scroll down, and I'm going to turn it on. Okay, so I just pressed enter, enter. Okay. Now I'm going to graph it. There, I can see my data points, just like what they look like in the diagram on your note sheet. Okay, so the next thing I'm going to do is I'm going to perform a function called linear regression. This linear regression function you can do right on your calculator, and instead of us manually drawing this line in, the calculator is going to do it for us. So on your calculator, press the stat button again, and now instead of editing the list, we're going to calculate a list. Okay, so just scroll over, calculate, and then scroll down to number 4. This is our linear regression. So our x list is going to pull from list 1, because that's where we put our x values. Our y list is going to pull from list 2, because that's where we put our y values. And then we're actually going to store this regression equation into the y equals. So to store it, I'm going to click this vars button for variables. And I want to store it into one of my y variables. I want to store it as a function. So I'm going to choose number 1. And y1 is good. I'll just select y1. Now I'm going to calculate. So now I get this equation, y equals ax plus b. That's in slope-intercept form, where a is your slope. And I get this equation, y equals a, which is 94, times x plus b, which is 555. So I'm going to go ahead and type that equation into my notes. Y equals y equals 94x, 94x plus 555. Oh. So as you need to review or rewind this video, please pause and do so. But my equation that I get is y equals 94x plus 255. Or sorry, plus 555. Now, if I graph this, now I can see that line of best fit. So in my calculator, I graphed it, and I could actually see a best fitting line. Option C says, or letter C says, graph the best fitting line, use the trace feature and the arrow keys to find the value of the equation when x equals something. So I'm just going to use the trace function here, and I'm tracing along my line. Oh, it's going on my points. There we go. Okay, I'm tracing along my line. And so now along this line, you see how my x values and my y values are changing? So here it says x equals 1.89. When x is 1.89, my y is 7.33. Okay, so I can scroll along this and find any y value I want when x is any x value I want. So after about 1 year, my y value is $647. So almost at the 1 year mark, 0.98, my y value is 647, meaning after 1 year, the average NFL salary is $647,000 because this is measuring data in thousands. If I actually plugged this value in to my equation, which I did, after 1 year, I get $649,000. So you can use your trace function. And here you can see 94x plus 555. You can see how they traced it exactly to 1. Okay, let's look at the second example. It says, look back at example 1. Use the equation from example 1 to approximate the average NFL player's salary in 2002 to 2003. The first thing you have to remember is that we used an x value of years since 1997. Okay, so x is equal to years since 1997. So over here, in this example, we're looking for the average salary in 2002. Well, the first thing I'm going to do is change that to my actual x value. So in 2002, my x value is 5. In 2003, my x value is 6. Okay, so that's the first thing I'm going to do, is think about how it relates to my x and y. So in 2002, the average NFL player salary was actually $1180, and in 2003, so this, again, that's my x value, that's my y value. In 2003, where x is 6, the average NFL player salary was actually $1259. Describe the accuracy of the extrapolations, so that's outside of our data set, made in part A. Okay, so again, x is years since 1997, y, my equation that I came up with using my calculator, is y equals 94x plus 555. So we want to look at the data, and we want to see the accuracy of our equation. So when x is 5 and x is 6, so I'm going to go ahead and plug those values in for x. So 5 and 6. Using the model is going to predict an average salary of $1,025 when x is 5. And when x is 6, they're going to predict $1,119,000 in 2003. And I can do that just using my calculator. So if I go back to my main screen, I'm going to use my equation 94 times 5 plus 555, and 94 times 6 plus 555. Okay, so that's how I got those values. Now in part B, it says the differences between the predicted average NFL player salary and the actual average NFL player salary in 2002 and 2003. So we need to find the actual difference. So we predicted after 5 years it would be 1025, but it was actually 1180. So that's a difference of $155,000. Oops, 155. Okay, and the way I did it, it's negative, but the difference is still just between what we expected and what we predicted and what we actually had. So we predicted $155,000 less than what they actually made. And then in 2002, which was 6 years after 1997, we predicted $1,259, but we predicted 1,119, but they actually had 1,259. So I'm going to do the same thing. I'm going to take 1,119 minus 1,259. Oops. Okay, and I get $140,000 difference. So the equation of the best fitting line gives a less accurate prediction for the years outside of the years that are given. Okay, so as I would graph these, see how I'm still pretty far, like I'm not on the line. Okay, so as I get further away, I have less data to go on because it changes every year. The average is going to be different every year. So we're less accurate if we're working with data outside of our range. It's just a prediction, but if we're predicting within a given time period, we're more accurate than if we're predicting outside something that hasn't happened yet. Okay, let's look at this key concept part. So in chapter 3, we learned how to solve an equation like 4x minus 4 is equal to 0. So we said 4x, we're going to add 4 to both sides, 4x is equal to 4, and then divide both sides by 4, and we get x is equal to 1. So the solution of 4x minus 4 equals 0 is 1. That's the solution for x. Okay, it's x equals 1. In chapter 4, we found the x-intercepts. Of a graph of a function like 4x minus 4. So the x-intercept was when y was 0, and then we solved for x. Okay, using what we learned in chapter 3. And now we're going to find the 0 of a function like f of x equals 4x minus 4, where f of x equals 0. So we have to set the equation of the function 4x minus 4 equal to 0. If you look back at what we learned in chapter 3, that's exactly what we learned how to do in chapter 3. We just didn't know why we were doing it. Okay, so again, we're going to add 4 to both sides and divide by 4, and we get x is equal to 1. Therefore, the 0 of f of x equals 4x minus 4 is 1. Okay, now let's look at this last example. In this last example, we're finding the 0 of a function. Okay, so finding the 0 is what is the y value or what is the x value when y equals 0? That's what we need to find. We need to solve for x when the function is equal to 0. So it says the percentage Y of people in the US that use public transit to commute to work can be modeled by the function y equals negative 0.045x plus 5.7, where x is the number of years since 1983. So again, since 1983. Oops. Find the zero of the function. So what is x when y is 0? So we are going to change this. We're going to set this equal to 0. So we are going to substitute 0 for y in the equation y equals negative 0.045x plus 5.7. Okay, and this is the best fitting line. Okay, so we have our equation. We're going to substitute 0 in for y, and now we're going to solve for x. So to solve for x, we have to subtract 5.7 from both sides. Negative 0.045x is equal to negative 5.7. And now I'm going to divide both sides by negative 5.7. So I have negative 0.045, oops, negative 0.045 divided by negative 5.7. And I get 0.00, oh, that's not right. I divided by the wrong thing. Okay, so actually what we need to do is solve for x. So we need to take negative 5.7 divided by negative 0.045. We need to divide in order to isolate x. And when we do that, we get 126.66666 repeating. Now, we're already working with decimals, so it's okay to use decimals in our answer. So now we can say that the zero of the function, or x approximately equals that squiggle equal sign means approximately equal to, and it's approximately equal to 127. I'm just going to round to the nearest whole number. So now we can say that the zero of the function is about 127. The function has a negative slope. We know that because we can see that right here in our equation of our line. Okay, the slope is negative, which means that the percentage is decreasing as time increases. So according to this model, there will be no people who use public transit to commute to work in 127 years after 1983. Oops, 1983. So what year is 127 years after 1983? 1983 plus 127 is 2110. So in the year 2110, nobody is going to be using public transit to commute to work. Okay, there's one checkpoint question on your notes, so please do this on your own. You can pause the video while you work, and when you unpause, I will go through the solution. My first step is to enter this data into my calculator, into my list. Then I'm going to get my linear regression equation. So I'm going to go to Stat, Calc. Number 4 is linear regression. And I'm going to store it in my y equals 1. So vars y vars function y equals 1. And then I'm going to actually calculate this. So here's my actual equation. So now I could use my equation to predict the average player salary in 1998, or anything outside of this data I could use this equation for. You could have rounded y equals 201 plus 1293 or something like that, but I would say in general round to 1 decimal place at least. So please jot down any notes or questions you have. You can watch this video as many times as you'd like, and we'll go over questions next time I see you in class. Thanks.